Okay, hello everyone, it's Salar and we are in part 32 of our tutorial, a tutorial to writing a real-time operating system. Okay, in previous part, I talked about dynamic memory allocation, malloc function, free function, sbrk function, and other things about dynamic memory allocation. Okay, but in this part, I want to start talking about interrupt and exception. Okay, concept of interrupt and exception, especially in ARM processors and ARM Cortex-M processors. Okay, what is interrupt and exception? You probably know what is interrupt. Interrupt is an event that causes a change in the program flow of your processor. Okay, and when your processor running its instruction, when an interrupt occurs, your processor jumps to an interrupt handler, a function, a part of your code, running instructions for that interrupt, for that specific interrupt, and like function in the end of that return to your program flow and running the rest of your instruction in your program flow. Okay, but I say many of you has a lot of information about interrupt in microcontrollers, and you can't find a lot of information about interrupt in our processor on the internet and on documentations. Okay, and interrupts in ARM processor is a straightforward topic. Okay, you can find a lot of information about that, but let's give you some information. What is interrupt and exception, and what is the difference between interrupt and exception in ARM processor? Okay, it's a list of, for example, all of your interrupt and exception in Cortex-M processor. Okay, you can find a lot of information about interrupt and exception in, for example, Cortex M7, M4, M3 generic user guide. Generic user guide. Okay, you can, for example, I have generic user guides of Cortex M7 microcontroller here. Okay, you can find a lot of information about interrupt and exception in ARM, your core processor generic user guide. Okay, you can download this document from ARM documentation website. Okay, and you can find a lot of information about interrupt and exceptions. Okay, but what is differences between interrupt and exception in ARM processor? Here, these are until here. Exceptions in ARM processor. The concept of interrupt and exception are identical. Okay, all of them are interrupts, jumping to interrupt handler and reset to your program flow. But exceptions in ARM processor issued by core, okay, and refer and related to core of your processor and implemented in the core of your processor. But interrupts are implemented in peripheral and related to the peripheral of your specific microcontroller. Okay, and for example, a interrupt in NXP microcontroller and SD microcontroller are different. Interrupts are different, okay, in different microcontrollers. And what is a vector table? Vector, or you can say that address table. Okay, but what is vector table and address table? As I said in previous part, the vector table is in the start of your program, in the start of your flash memory. For example, in my microcontroller, vector table started from this address, start the flash of my microcontroller. You can change the space and address of your vector table, but the default value of this table, this default start address of this table in my microcontroller is in this address. Okay, you can see the vector table for Cortex M7 microcontroller, for example, in the startup file of your processor. Okay, for example, here I have my vector table. Okay, the list of exception and interrupts. Okay, interrupts can be different in different microcontrollers. Okay, for example, in the first word in your vector table, you have stacked up. After that, you have an address. Okay, after stacked up, you have an address, for example, for reset exception. When you have a reset exception, your processor jump to this address here. Okay, or for example, for a specific microcontroller, for example, for my microcontroller ST microelectronic from ST microelectronic, here is the startup of my microcontroller. Like other Cortex M7 microcontrollers processors, the exception related to core and list of your interrupts related to your peripherals. For example, for I2C, timer, external interrupt, serial CAN port, and other things. Okay, this list can be different in different microcontrollers. Okay, because of that, in the startup of CMCs, I just have exceptions. I don't have information about interrupts. Okay, because it's a generic startup for all of Cortex M7 microcontrollers. Okay, but let's describe an example to give you more information about interrupt and exceptions and vector table. Okay, let's describe, for example, systematic handler exception, a part of your processor. What is systematic timer? It's a part of your Cortex M7 processor. The system timer. Systematic is a 24-bit countdown timer, and you can use this timer to create repetitive interrupt with constant time interval. Okay, it can be so useful to implementing real-time operating system. Okay, but in the start, after reset, all of your exceptions are enabled. Okay, and you can for example, config systematic timer by this CMSIS function. Okay, by setting this argument and this function. But what is this argument? With this argument, you can set the time interval between interrupts according to this formula. This argument multiplied by the core clock frequency, the clock frequency of your core. Okay, you can set a time interval. Okay, for example, here I have an example. You can config system tick timer, for example, like here. You can put argument. You can put in argument this number, your core clock frequency multiplied by 1000. Okay, and according to this formula, the time interval between these interrupts will be 1 millisecond. Okay, so with this configuration, you will have a repetitive interrupt. Okay, with this time interval, and it can be so useful to implementing real-time operating system. Or if you, for example, put 500 here, you can have time interval as 2 milliseconds. Okay, so let's see this example in Eclipse and give you more information about a vector table, exception, and interrupts. Okay, here is an example, and in this example with systematic exception, I want to do LED blinking. I want to do a project, and the project is LED blinking. Okay, in each 500 milliseconds. Okay, as I said, you can config the systematic timer with this function from CMSIS. Okay, what is core clock frequency, for example, in my microcontroller? The default value is here. Okay, for example, in my microcontroller configuration, my clock frequency, core clock frequency is 16 megahertz. Okay, but if you have changed the value of your core clock frequency, you should change this value. Okay, so here is system tick config, and here is LED configuration to do LED blinking. I said in previous part, if you want to use IO port, you need to active its clock and make it as an output pin. Okay, I've done that in LED config. Make it output and active clock of this pin. Okay, pin of my LED on my board. Okay, but let's do another time see the startup. When you have an exception or interrupt, for example here system tick, your processor will jump to this address. But where is this address? The default of this address defined here in this part of your code in your startup. Okay, with, for example, here system tick timer with this macro. Okay, with this macro you can find a lot of information about macro in your assembly program in assembly user guide of GCC. Okay, documentation of GCC. Okay, for example here for system tick, as you can see, for all of this exception and interrupt, according to this macro, your processor will jump to this address, default handler, and you have an infinite loop here. Okay, but as you can see, the handler name system tick defined as a weak symbol. Okay, and is a weak symbol, and you can redefine that with an strong symbol. As you can see, I defined this symbol here, system tick. So when you have an interrupt, your processor will jump to this system tick handler. Okay, in each 1 millisecond your processor jump to this function, and after that return to the program flow. As I said here, jump to interrupt handler, for example system tick handler, and return to the program flow. And according these parts of interrupt handler, this if statement, if and else statement, each 500 times, just one time running this part of your code, this if, and do LED toggle, LED blink. Okay, in each 1 millisecond you will have an entry to this function, to this interrupt handler, exception handler, and in each 500 times of running this handler, just one time you will have LED toggle, you will have this part of your code. Okay, and you have an LED blinking in each 500 milliseconds. Okay, let's see this example on my board. Build my project and run the debugger. Okay, let's do run my code and see my board here. As you can see, I have LED blinking in each 500 milliseconds. Okay, very good, with system tick timer and exception and interrupts. Let's go back to our code. Okay, according the vector table in your startup file here, okay, it can be different for different microcontrollers in this part for interrupts. Okay, if you have an interrupt or exception, your processor jump to an address. Okay, for example, for system tick handler, the default value is a weak value here, the default handler, but you, because of this weak definition, you can redefine your handler. Okay, So here was some information about exception and interrupt in ARM processor and microcontrollers and vector table. Okay, but this number 0 to 239 can be different in different core. For example, in Cortex M0 processor, you have fewer number of interrupt requests. For example, I think between 0 to 47. Okay, I'm not sure, but I sure the number of interrupts in Cortex M0 is smaller than, for example, Cortex M7. Okay, but let's to give you some information about ARM processor facilities. Okay, that's related to interrupt and exception. One of that is privilege access level. Okay, ARM privilege levels. But what is privilege levels? We have two privilege access levels in ARM processor: ARM privileged and privileged. What is differences between unprivileged and privileged? When you are in unprivileged level, you have some restrictions. For example, you can't change the value of these registers. That's known as core special registers. You can see your core special registers here in generic user guide. Special registers. Okay, for example, here you have a table. That's in this table you can find your special registers. Okay, here you have some special register, and you can change the value of these registers by these CMSIS functions or by MSR or CPS instructions. Okay, you can find a lot of information about these instructions in ARM architecture reference manual. But in unprivileged level, access level, you can't change the value of these registers. Okay, and the value of these registers are unchangeable. Or you can change the value of your interrupt configuration registers in NVIC part of your microcontroller. NVIC part is a part in the core of your processor that's related to configuration of interrupt and exception in your processor. Okay, or you can change the value of register in this part of your processor, system control block, and you have some restriction when you defined some protected part in your memory. Okay, with MPU. I will do just some information about memory protection unit in future parts. Okay, but in privilege level, you don't have these restrictions. Okay, you can change all of these registers and you can use this instruction in privilege level. But how you can active privilege or unprivileged level in your processor? Let's give you some information. I should say after reset, processor will be in privileged level. Okay, after reset, you can easily change the value of these registers and you can use these instructions, okay, to change the value of, for example, these registers. Okay, but you can change the level of your processor to unprivileged by changing the value of this register in bit 0. Okay, if you were in privileged level, by changing the value of this register bit 0, from 0 to 1 you can jump to unprivileged level. But in unprivileged level you can't return to privileged level because you need to change the value of this register. And in unprivileged level you can change the value of control register. But how can I return to privileged level from unprivileged level? I will say you in next slides. Okay, so let's see an example to changing the access level of the processor. Okay, here I have a code part, and in this code I want to change the value of I want to change the access level of my processor from privileged to unprivileged. Okay, for example, you need to change the value of control register. Okay, you can see the value of control register in here. Okay, here I have control register is 0. The value of control register is 0. So the bit 0 is 0. So after reset, I'm in privilege level. Okay, you can read the value of this register by this CMSIS function. Okay, after that, you can change the value of bit 0 with this code. Okay, or the value of control register with this value, and put the value of control register this value. Okay, with this code you can jump to unprivileged level. Let's run the code. For example, here control register is 0, and after that set it to 1, the bit 0 to 1. Okay, as you can see, the bit 0 is 1. Okay, the bit 0 is 1, and now I'm in unprivileged level. Okay, and with this code I want to return to privileged level. Let's run that. The control register is unchangeable because I'm in unprivileged level, and from unprivileged level you can't return to privileged level directly. Okay, but I will say you how you can return to privileged level in next slides. But let's give you some another examples. Okay, now see this example. Another time I want to configure systemtic timer and do blinking, but after configuration of systemtic, I've disabled all of exceptions with this CMSIS function. Okay, with this CMSIS function you can disable all of your exception and interrupts. Okay, so let's run and see the result on the board. Okay, run that, and now see the board. I don't have blinking. Okay, I don't have blinking on my board. Why? Because I've disabled all of exceptions by this function. Okay, by the CMSIS function. Now let's see another example. Okay, now in this example, after configuration of systemtic, before to disabling exceptions, my processor jumps to unprivileged level by this part of the code. Okay, let's another time see the result on the board. Okay, run the project and see the board. As you can see, now I have blinking. Why in this example I have blinking? Because before this function I've jumped to unprivileged level, and in unprivileged level you can disable your exceptions. Okay, because in this function you need to use CPS instructions. Okay, you can find a lot of information about CPS instructions in ARM architecture reference manual. Okay, and in ARM, in unprivileged level I can't use CPS instruction. Okay, these were some information about access level in ARM processor. But before describing how we can return from unprivileged to privileged level, let's see more information about ARM processor. Another facility of ARM processor is ARM processor mode. Okay, ARM processor mode. But what are ARM processor modes? What are ARM processor modes? We have two modes in ARM processor, handler mode and thread mode. But what is the differences between handler mode and thread modes? Let's describe that with this in this slide. Okay, when you are in your program flow, you are in thread mode. But when your processor jumps to an exception, you are in handler mode. After returning from interrupt another time, you are in thread mode. Okay, so when you are in an interrupt or exception handler, you are in thread mode. Okay, but when executing an exception handler or interrupt handler, in handler mode, processor always has privileged access. Okay, so for example here in this example, after this line your processor jumped to unprivileged level, but when your processor jump to this function, you are in handler mode and privileged mode. Okay, in handler mode you have just privileged mode and your processor doesn't care to this bit. Okay, but when you are in thread mode, you can be in privileged level or unprivileged level. Okay, so I should say after exceptions, okay, after exceptions processor will be in privileged handler. Okay, when you are in an exception, you are in handler mode and privileged mode, except reset. After resetting your processor, you are in privileged and thread mode. Okay, you know, after resetting first part and first lines of your code, you are in thread mode and privileged mode. Okay, you can use this register to see the processor mode. Okay, you can use this register to see the processor mode of your processor. Okay, here I have IPSR register. Okay, when the value of these bits are 0, you are in thread mode. Okay, and when this value is not 0, you are in handler mode and one of your interrupts or exceptions. Okay, let's see an example in Eclipse. Okay, another time blinking example. When you are in your thread mode, you can see in XPSR is the combination of APSR register, IPSR register and EPSR register, but in bit 0 to 8 you have information about the mode of your processor. Okay, now after the reset in main function, the value is 0, so I'm in thread mode. Okay, I'm in thread mode, but let's jump to systematic handler. Okay, now I'm in systematic handler, but the value is F. Bit 0 to 8 is F. Okay, let's see what is this value. Another time search for IPSR register. Here, the value of F or 15 is systematic. Okay, now I'm in handler mode and systematic mode. Okay, I'm in handler mode. Okay, if another time jump to the thread mode, the value of bit 0 to 8 is 0. Another time in thread mode. Okay, so let's do back to our slides. So with these bits in IPSR register, you can see the processor mode, but as I said, in thread mode, you can be in privileged level or unprivileged level. Okay, by changing the value of control register, you can jump to unprivileged level, but you can't return from unprivileged level to privileged level. Okay, but as I said, when you are in thread mode, by interrupt in try, your processor jump to handler mode. Okay, thread unprivileged or privileged. Okay, your processor jump to handler mode, and in handler mode you just have privileged level, and from handler mode you can return to thread mode privileged level or thread mode unprivileged level. But before returning from interrupt, you need to change the value of control register. Okay, if you want to return to unprivileged level, you can change the value of this register to 0 to 1, but if you want to return to privileged level, you can change the value of this register to 0. Okay, so in this way you can return to privileged level from unprivileged level. First, jump to an interrupt. Okay, after that, from this way you can return to privileged level. Let's see an example in Eclipse. Okay, in this example I want to change the access level of my processor to unprivileged level. Okay, by this part of my code, okay, so let's as you can see, the value of control register is, where is control register? Here is 0. Okay, I'm in privileged level after reset, but let's run this part of the code. Okay, I'm here and the value of register is 1. I'm in unprivileged level, but let's jump to the handler mode. Okay, here in system tick timer, and in this part of the code I want to change the value of this register to 0 another time and back to privileged level. Okay, delete this breakpoint, and okay, now I'm here. As you can see, another time the value of control register is 1. Okay, but because I'm in handler mode, your processor does not care to this register, and you can change the value of your control register in handler mode. Okay, run this line of code. Now the value is changed to 0 and I'm in thread mode. Okay, and return from system tick handler, I'm in thread mode here, but the value of this register is 0 and I'm in privileged level. So if you want to jump to unprivileged, you can use this register. Okay, but if you want back to privileged level, first you need to jump to handler mode. After that, by changing the value of this register to 0, jump to thread mode and privileged level. Okay, and in unprivileged level you have some restrictions. Okay, and you have more security when you are in unprivileged level, and the program can change the most important part of your code. Okay, so you can use privileged level and unprivileged level to implement security in your program. Okay, this was some information about interrupt, exception in ARM processor, vector table, and some information and some facilities of your processor, access level and mode of your processor. Okay, these informations are so important when you want to develop an operating system. Okay, I will use this information in future parts, okay, to implement a secure real-time operating system and a very good real-time operating system. Okay, so thank you very much to see me, and see you soon in the next part. Thank you very much.